now. So I prepared a timetable for you, and Wednesdays we're going to be meeting for math, and every time we meet for math or any other subject, we'll be able to start a topic and finish it, because I want by July we should be done learning, so that we just focus on continuous past paper revisions. So our topic today is mathematics. Like I said, we're going to start off with algebra to build that foundation before we make a transition to start doing those harder topics that you're going to require if you want to do well in math, especially for paper 2, which carries a lot of marks and which is rather easier, because you have to focus mostly on paper 2, because paper 1 mathematics is going to be slightly challenging because you do not have a calculator. So I want you to develop an adequate pace for you to be solving mathematics. So be accurate, but also have enough speed for you to solve the question. So accuracy and speed should be your best friends when it comes to solving mathematics. So today, we're going to have a look at algebra. And I think we're going to end on, we'll do numbers. We'll do a little bit of, for now, I think we'll focus mostly on numbers, and we'll do a few exam questions. Then in our next class, we're going to do the addition part of algebra, multiplication part, expansion, changing the subject, algebraic fractions, and also algebraic equations. All right, so last time I told you that mathematics is a language, and since math is a language, you have to be able to know a few definitions. So the first definition that I want you to learn about is integers. What is an integer by definition? So for me, I like to define an integer as simply those numbers that appear on a given number line. So if you have a number line like this, I'm sure you've been seeing number lines since grade 3. But those numbers that you indicate, that you write on a number line, are actually integers. So integers are numbers. They are positive numbers or negative numbers that can go from 0, +1, +2, +3 to infinity. Do you know what infinity means? This is the symbol for infinity. So infinity, that's the symbol. I want you to know the symbol of infinity. Infinity means it doesn't have an end. You can continue counting these integers from 1 to a trillion and something, they'll never come to an end. That's what infinity means. So integers are numbers on a number line. They can go from 0, +1, +2, +3 until infinity. Or they can go from 0, -1, -2, -3 until infinity. So integers, they are positive integers and also negative integers. Have you understood the definition of integers? You've understood, right? All right. By the way, make sure when I send you this video, make sure you watch it over and over again and get your math book and actually write down this lesson plan. So where it says numbers, integers, natural numbers, I want you to write down everything that we're doing right now physically in your mathematics tuition book. Do you understand what I'm saying? All right. So I like to consider natural numbers as just normal counting numbers that prepare the mindset of preschoolers towards just counting. So natural numbers, every preschooler or someone in nursery school, they don't have an idea what 0 is. They just want to know how to count. So I call these, I like to call natural numbers as preschool numbers because they're just normal counting numbers. And usually they are positive integers. When I say they are positive integers, I mean that when we are talking about natural numbers, we are starting from 1, 2, 3, 4, 5, etc. until infinity. So these are like, preschool numbers, number 1, number 2, number 3, up to 10 until infinity. Those are natural numbers. There is no zero when we're talking about natural numbers. However, when someone who's in preschool starts to reach maybe grade 1 or grade 2, etc., they'll start learning mathematics. They'll start learning how to add simple things, how to subtract simple things. Therefore, the teachers themselves introduce this zero here. And numbers that have a zero in them, that start from zero up to infinity, and they are also positive integers, are known as whole numbers. This way they are whole numbers. The way that I remember that whole numbers start from a zero, this here, you've seen this O in the word whole numbers. This zero represents that a whole number is going to start from 0, 1, 2, 3, 4, 5, etc. until infinity. They never come to an end. So these are the numbers that prepare these school kids, even us, to now start doing our addition, our subtraction, our multiplication, where you introduce the zero, you introduce mathematics. So you started learning mathematics when the concept of zero was introduced to you. So those are what we call whole numbers. All right, so sometimes there is a very interesting concept that's very important in mathematics that can actually even come as a question. Um, it's the concept of real numbers, rational numbers, and irrational numbers. Real numbers, rational numbers, and irrational numbers. So you have seen decimal numbers before, right? For example, you have seen something like, let's say, 2.56. Every time we have this point here and certain digits, this is a decimal number right there. So any number that can be expressed as a decimal is known as a real number. If I have a whole number like this, let's say this is a whole number like 65, I can express 65 as a decimal by adding a decimal point right at the end of it there. That would be 65.0. So this whole number can be expressed as a decimal. So any number that can be expressed as a decimal is known as a real number. And remember, decimal numbers, we count these decimal points starting from this point there. And please, Fabe, I do not want you to ever read the decimal number as 2.56. I'll be very upset. Every time you add the decimal point, those digits are read individually as whole numbers. Don't say 2.56. Don't say 3.75. Do not say that. Every time you have a decimal point, you read these numbers individually. Therefore, this will be 3.75 and this will be 2.56. So that's the definition of real numbers. So what about rational numbers? So a rational number is any number that can be expressed as a fraction. So if you if you can express that number in a fractional form, that number becomes rational. Rational in that it makes sense. If you can express it as a fraction, it means it's rational, meaning that number actually makes sense. So what's a fraction by definition? So a fraction has got two components. A fraction has got two components. By the way, you have to learn how to add fractions, you have to learn how to divide fractions, you have to learn how to multiply fractions. So if I say a fraction like this, a fraction has to have two components. It has to have a numerator. Know these definitions. A numerator, which is above the fractions. Then it will have a division line, then it's going to have a denominator which is at the bottom of a fraction. So if I say 7 over 16, this 7 here above is the numerator, and this 16 below is the denominator. So this is a form of a fraction, and this fraction is known as a proper fraction. So when we say a proper fraction, it means the numerator here, the number appearing above, is much smaller than the denominator. That's a proper fraction. If we say an improper fraction, it means the denominator right here will be much bigger than, oh sorry, the numerator will be much bigger than the denominator. This is an improper fraction. A proper fraction, the numerator is smaller than the denominator, very normal looking. But an improper fraction, the numerator here will be much bigger than the denominator. A mixed fraction will have a whole number like this, maybe let's say a whole 3, 5 over 19. This here is a mixed fraction. It's going to have a divisor there, this whole number, a whole 3, 5 over 19. So if we can express numbers in terms of fractions, those numbers are known as rational numbers. Are we together, Fabi? We're together, right? All right. Let's move on to a concept known as irrational numbers. So irrational numbers, when it becomes irrational, it means we cannot express that as a fraction. So this is the basic definition that I want you to know about irrational numbers, because at a GCE level, at high school level, we don't have to prove whether a given number is an irrational number or not. That's A-level math. But we have to know the definition of an irrational number as a number that cannot be expressed as a fraction. And a good example of an irrational number is pi. This pi, even if this pi is an irrational number because 2.146 etc, it goes until infinity. You cannot express this decimal number into a fraction. By the way, what do I mean? If I say 2.56, if I want to express 2.56 into a fraction, I'll start counting the decimal places that we have. This decimal place here will be a tenth. This decimal place here will be 100th. So if I want to express this as a fraction, it will be 256 over 100. 256 divided by 100, it will get back to, if you divide this here, you're going to get back to 2.56. Therefore, this number is rational. However, look at pi, 2.146, the numbers keep on going until infinity. Therefore, we cannot express this number as a fraction. It becomes an irrational number. Another example is the square root of 2, the square root of 8, and also I didn't include it here, but the square root of 7 is also an irrational number. So if we can't put that number as a fraction, if we can't have the numerator above and the denominator below, we cannot express that number into a fraction. It becomes an irrational number. I think a number that I should also introduce here is something known as undefined. Undefined. Have you ever heard of undefined? You've never heard of undefined? All right, I'm going to tell you what undefined means. If the denominator is 0, that number is going to become undefined. So the denominator should never be 0. If I say maybe 6 over 0, there will be no solution here, because what are you dividing 6 with? You're dividing it with nothing. So that becomes undefined. This is the terminology that you have to know throughout mathematics. If you don't know the terminology, if you don't know how to define the terms, you'll be stuck and you're going to hate the subject itself. So undefined means that the denominator is zero. The denominator should never be zero. The denominator should never be zero. If the denominator is zero, that number will become undefined. Is that all right?
Mm.
Okay. Please write this in your book with the aid of the video that I'm going to send to Charity later on today. Immediately after the lecture, actually, I'll send you the notes as well as the video. So prime numbers. Prime numbers, examiners love prime numbers. Why? They can bring something known as prime factorization. Prime factorization. I'll show you this probably in the next class. Or maybe they can say you've been given a universal set and they add numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the universal set. Then they say list set a set of prime numbers. List set a set of prime numbers. That's the first question there, and they've even put 2 marks. They usually, trust me, ECZ loves prime numbers. I don't know why, for some weird reason. Maybe it's an easy question. Maybe students forget the definition of a prime number, but it's a good thing I'm here so that you don't forget the definition of a prime number. So a prime number is a number that can only be divided by one and itself. But the interesting part about prime numbers is that they are positive integers. We do not have negative prime numbers. So a prime number is only divisible by one and itself, and it's a positive integer. It's always a positive integer. It means there is no negative. It's a positive integer that is greater than 1. It's a positive integer that is greater than 1. 1 is not a prime number because 1 is actually divisible by 1. So 1 is not a prime number. Prime numbers can only be divided by 1 and itself, and it's a positive integer that's greater than 1. So here are some examples. 2 can only be divided by 2 and itself. 3 can only be divided by 3 and itself. 5 can only be divided by 5 and itself. 7 can only be divided by 7 and itself, by 1 and itself. 11 can also be divided by 1 and itself. So these are prime numbers. They are only divisible by 1 and themselves. So let's try and answer this question that I created here. We have got set E, the universal set. By the way, a universal set is represented by a capital letter E, or sometimes they're going to use this fancy italicized E. It's a weird form of E. It looks something like this. So a universal set can be written as this fancy looking E like this, or just a capital letter E. Universal set is a set of all sets, like all elements are found in that universal set. And using the universal set, you can create other smaller subsets. They are called subsets. So you can make other little minute smaller sets from the big set known as the universal set. So now that we know the definition of a prime number, we have this universal set here. The universal set is going from 1 to 10. The question says list set a set of prime numbers. Therefore, our set A will be equal to, open the parentheses, our prime numbers here. We now know the definition that a prime number is only divisible by 1 and itself, and 1 is not a prime number. So our prime numbers there from 1 to 10 will be 2, 3, yes, 5,
One.
exactly, and 7. Wow, wow, excellent. So our set A will be 2, 3, 5, and 7. And like that, you get your 2 marks. But a student who has never done numbers and a question comes on sets like this, will be like, what the heck is a prime number? How am I supposed to answer this question? No wonder this foundational topic is very, very essential. What other numbers am I left with? All right, these are the final two numbers I want you to know. So even numbers, these are just numbers that are divisible by 2. So it's like 2, 4, 6, 8, 10, 12, 16, etc. So these are known as even numbers. So if a number is divisible by 2, it's known as an even number. However, if a number is not divisible by 2, it becomes an odd number. So maybe 3, 5, 7, 9, etc. These are known as odd numbers. So an even number is a number that's divisible by 2, and an odd number is a number that's not divisible by 2. I didn't add one more type of number. Let me just add one type of number known as a square number. Square numbers. So a square number is just a number that can be expressed as a square of itself. What do I mean? They start from 2. If I say 2 times 2 is 4, meaning the square root of 4 is 2. 3 times 3 is 9, meaning the square root of 9 is 3. 4 times 4 is 16, meaning the square root of 16 is 4. So that's what I mean when I say a square number. And by the way, for the sake of quadratic equations, for the sake of quadratic equations, a square number has a positive answer and a negative answer. I'm repeating this again so that I don't have to repeat it again when we do quadratic equations. A square number has a positive number and a negative number. So if we say the square root of 4 is positive 2, for us to be correct, for us to get marks, the square root of 4 is actually either positive 2 or negative 2. The square root of 9 is either positive 3 or negative 3. The square root of 16 is either positive 4 or negative 4, and so on. So for the sake of quadratic equations, again, I'm repeating this. A square number can either have a positive number or a negative number. Let me even make it more complex. A square number can either have a positive integer or a negative integer, because now we know the definition of integers. An integer is a number on a number line. It can either be positive this side of the number line or negative on the other side of the number line. So talking about integers, for the sake of paper 1 and also for the sake of paper 2, we have to be able to know how to evaluate integers. We have to know how to add integers, we have to know how to subtract integers, and we also have to know how to multiply and divide integers. Very, very, very important, because you can make an integer mistake when you're substituting. If you don't add that integer properly, if you don't multiply that integer properly, you will make an error and you'll probably get that answer wrong. So how am I able to remember this? You can say, can you say plus minus? Fabi,
Yes.
can you say plus minus?
Plus minus.
All right, thank you. So once you say plus minus, you can just include these things. You can just say negative times negative, it's positive. Positive times positive, it's positive. Then the last one, you just say negative times positive, it will be negative. Then you do the same thing. You just say plus minus. Then you say negative divided by negative, it will be positive. Positive divided by positive, it will be positive. Then negative divided by positive, it will be negative. So if you are not familiar with integers, adding them and dividing them, you can use this for now. You can maybe even write it down somewhere and then just practice these questions. I want you to practice. We're going to solve these questions together, but I want you to practice these questions over and over until you until you understand how to solve all of them. So we're going to start off with this one here. It says negative 3 plus 5. Negative 3 plus 5. Let me write this side. Negative times negative, it's positive. Positive times positive, it's positive. Negative times positive, it will be negative. Plus minus, then we do the same for division. Negative divided by negative, it's positive. Positive divided by positive, it's positive. Negative divided by positive, it's negative, so that I can use this other space for us to solve these other questions. So let's start off from the first question that we have here. Our first question says negative 3 plus 5. Negative 3 plus 5. So in a grade, I don't know if it's grade 1 or grade 3. I'm sure I think it was grade 3 or grade 4, somewhere there. To solve integers, we used to draw number lines. So maybe your teacher would have asked you such a question like negative 3 plus positive 5, and you would draw a number line like this. Then you'd say, okay, that's 0. Then you say 1, 2, 3, 4, 5, 6, infinity, it doesn't end. Then maybe this side you say negative 1, negative 2, negative 3, negative 4, infinity, it doesn't end. Then you're going to say, okay, it says a negative 3 plus negative 5. So maybe we, let me see this, maybe, okay, we start off from 0, and the question is saying we're starting by going negative 3 sides, 3 steps, and then you're going to say, okay, 0, 1, 2, 3. Then the question will be like, okay, then we're going to the positive side 5 times. Then we'll say 0, 1, 2, 3, 4, 5. Then you're going to say, aha, the answer is positive 2. Then your teacher is going to give you a mark for the answer, and they'll also give you a mark for the number line, and they'll say excellent, and they'll give you 2 stars for solving this question. We are in high school. We do not have time to draw number lines. There is a different method that you can use to find the answer without using number lines, and you have to be able to do it very, very fast. So here is how we're going to solve this question. The first thing that I want you to do is forget about the signs. Forget that here there is a negative. Let me highlight this. Forget that here there is a negative, and forget that here there is a positive. What you're going to ask yourself here rationally, you're going to ask yourself this question. What have I done? You're going to ask yourself this question. You're going to ask yourself this question. Which number is bigger between 3 and 5? Don't worry about the signs. So which number logically is bigger between 3 and 5?
5.
It's 5, right? So what is the sign on 5? Now you ask yourself, what's the sign on 5?
Positive.
A positive, right? Then meaning our answer will be a positive. Then you ask yourself, what's negative times positive? What's negative times positive? Negative times positive, it's what? Negative,
Positive.
right? Hmm? Plus minus, it's negative.
Wow.
It's negative, right?
Mm,
Meaning we are subtracting. What's 3 minus 5? It's 2. So that's how you find the answer. Step 1, you are going to try to figure out the sign of your answer. How do you try to figure out the sign of your answer? You ask yourself, which number is bigger between 3 and 5? The answer is 5, meaning our answer is going to be a positive. Then the second step, now you now look at your signs. You're like, okay, there's a negative sign and there's a positive sign. Then you ask yourself, what's negative times positive? It's negative. Meaning, since it's negative, you have to subtract. If it was positive, we would have added, but it's negative, meaning you have to subtract. So what's 3 minus 5? It will be 2, meaning our answer will be positive, positive 2. Let's try another one using the same method without using the number line this time. Just using the method of logic to sort of solve the question. Let's cancel that out. Cancel that out. Withdraw. So question 2. Question 2 says negative 7 plus 2, right?
yes, yes.
So step 1, we forget these signs. We forget the signs, and then we ask ourselves, which number is bigger between 7 and 2?
7.
7, right? And what's the sign on 7? A negative, meaning our answer is going to be a negative. All right, our answer will be a negative. Then we ask ourselves, what's negative times positive? What's negative times positive?
Negative.
Negative, right? Meaning we're subtracting. What's 7 minus 2? 2, 3, 4, 5, 6, 7. It will be 5. So our answer will be negative 5. That's how we solve these integers, following these steps. So when I send you the video, you have to follow these steps also. You watch the video, you pause, you write the topic, you write in your book, you try to understand, you watch the video, you pause, you try to understand, you write the answer in your book, just like that, just like that. This is how we're going to be learning. You're going to have a revision source. If you have to watch the video throughout the day, one video for introduction to math, until you understand everything, please watch the video, have a paper, have your book, practice. It's called active learning. You don't just learn passively, you get your book and start reading. No, you have to have a strategy before you study of how you're going to study. All right, so let's take a look at this one. This one's interesting. Question 3. It says negative 4 minus 4.
Mm,
This one's a bit interesting. Negative 4 minus 4. So the same method here. We forget the signs, and the first thing that we ask ourselves is, which number is bigger between 4 and 4? They're the same, right?
mm,
Meaning the answer will be a negative. The
yeah.
answer will be a negative, right? Then we ask ourselves, what is negative times negative? What is negative times negative here?
Yes,
It's positive, right? It means we're adding. What is 4 plus 4?
yes.
8. So that becomes our answer there. Not so bad, right? All right, I can see you're figuring out integers. I'm impressed. So let's move on to question 4. Question 4 says negative 2 plus 2, like that. Negative 2 plus 2. So again, which number is bigger between 2 and 2? They are the same, right?
Yeah.
So here we don't know they are the same, but they are carrying different signs. It wasn't like this one where they were carrying the same sign and we just took the answer there as our answer will be negative. But here they are carrying the same sign, so we do not know. But what's negative times positive? What's negative times positive?
Negative.
Negative, right? What's 2 minus 2? Mean we're subtracting. So what's 2 minus 2? 0. Meaning our answer would be 0. So every time you see this pattern, -1 plus 1, it will always be 0. -2 plus 2, it will always be 0. -3 plus 3, it will always be 0. -4 plus 4, it will always be 0. If you see such a pattern where the numbers are the same, and you can't figure out the sign of the answer, and you say negative times positive, it's negative, it means you're subtracting. So 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0, 4 minus 4, 0. And please, again, for the sake of algebra, if you see this same pattern and they add letters, don't get confused. If you see this pattern and they add letters, do not get confused. It's still the same thing. If they say minus x plus x, that would be 0. If they say minus 2x plus 2x, that would be 0. If they say minus 3x plus 3x, that would be 0. If they say minus 4y plus 4y, it will still be 0. When they introduce these variables here, these letters, they're not changing anything. They're just there to act as variables in an algebraic expression, and they are like terms. So we can add the like terms, we can subtract the like terms, we can multiply the like terms. So let's move on to question 5. Question 5, we multiplying an algebraic expression. This one is easy. So we're going to say -2 times 5. So we first figure out the sign of our answer. Negative times positive. Negative times positive, it's negative. 2 times 2, it's 10. So our answer is -10. We do the same thing for question 6. -15 divided by -3. We first figure out the sign of our answer. Negative divided by negative. Negative divided by negative, it will be positive.
Good.
Right? Exactly, excellent. Then we say 3 divided by 15, it would be 5. So our answer will be positive 5. So here our answer is positive 5, and here our answer is -10. So always follow this pattern, this plus minus pattern. If you forget, they just say negative times negative, it's positive. Positive times positive, it's positive. And negative times positive, it's negative. This plus minus, make sure you write this in your book. Write in book so that you do not forget this how to evaluate integers. So this is our last part of our lecture. So the last part of our lecture, we're going to solve 5 questions in terms of numbers. These are actual exam questions. And these are the questions that you're not supposed to be failing in the exam, because both in paper 1, maybe probably section A, the first 10 to 5 questions in paper 1, and in section B, in section A of paper 2 mathematics, you're going to find things like fractions, standard form, significant figures, decimals. Those things you're not supposed to fail, not even one question, because that's where your marks come from. In the exam, Your goal is not to answer all the questions. I'll repeat this. In an exam, your goal is not to answer all questions. Your goal is to answer the things that you know very well, effectively, without making mistakes. So you start with what you know, you solve them very well, such that you don't get them wrong. So if you know quadratic equations very well, you're going to answer quadratic equations very well and you won't fail. If you know statistics very well, you answer statistics very well and you won't fail. If you know trigonometry very well, you're going to go there in paper 2 and answer that question for trigonometry very well and you are not going to fail. It's about answering what you know properly, effectively, without making an error. It's not about answering all questions. Do you understand?
Yes.
All right. Let me just, I'll resume the recording. Let me resume the recording. So we have got question 1 there. We have got question 1, and it says express. So question 1 says express 7 over 100 as a decimal number, meaning a decimal number it's something that has a decimal point. So at the end of the day here, we need this 7 over 100 to have a decimal point somewhere. So how are we going to solve this? We're going to first say, all right, 100 into 7, it can't. I don't like using the word it can't because it sounds a little bit grade 3-ish, but we have no choice but to say it can't. So you add a zero, and then you introduce a decimal point there. That's okay, right? Then the next thing again, you say, all right, what am I doing? All right, then actually, yeah, you add a zero here also. No, it's fine. Then the next thing you say, all right, 7 into 7 again, it can't. So you add a zero and you add another zero there. That would be 70 now. Then you say, all right, 7. Okay, sorry, I've made a slight error. Let me wrap this. When you introduce the zero, you also have to add a zero and a decimal point there. So that's the error I made. So 7 over 100. So 7 divided 100 into 7, it can't. You add a zero there. And you add a zero and a decimal point. Was I wrong? Then you, all right, okay. So you add a zero there and a decimal point, and another zero there. So you add a zero there, and a decimal point. Then you say 100 into 70, it can't. So you add a zero there and a zero after a decimal point there. Then it becomes 700 there and it becomes 100 there. Then now you can finally say 100 divided into 700, it will be 7. So our answer there will be 0.07. Let's go through this again. We had 7 divided by 100. You say 100 divided into 7, it can't, right? So you add a zero there, then you add a zero there with a decimal point also. So for each zero, you're also adding a zero on the other side with the decimal point. Then you say 100 divided by 70. It can't. So you add a zero there and another zero there on the decimal point side. Then you say 100 into 700, it is 7. So our answer will be 0.07. Is that okay?
Yes.
So when you add a zero this side, you also add a zero this side. So our first zero is here, and we added another zero there. Then you put a decimal point, our DP, decimal point. Nowadays, DP has been changed in modern day society. When someone says DP, me, I usually mean decimal points. But nowadays, when people say DP, they mean their display picture on WhatsApp or on Facebook. Oh, what's your display picture? It's decimal point. It's not a DP. Then you are like, okay, into 70 it can't. So you added our second zero there and another zero there after the decimal point. Then it became 700. Then we said 100 into 700, it is 7. So our answer became 0.07. So make sure you practice these questions. Let me erase this so that we go on to question 2. Question 2 says express 0.08 as a percentage. Express 0.08 as a percentage. So a percentage is any number that's divided by 100. A percentage is any number that's divided by 100. Rule: every time you have a decimal number, whether it's 0.08, 0.7, 0.005, 0.25, every time you have a decimal number and you want to convert it into a percentage, always multiply it by 100. So just simply multiply the decimal, multiply the decimal number by 100. To convert a decimal number into a percentage, you multiply it by 100. So let's try to multiply this by 100. So every time you're multiplying our decimals, either by another decimal or you're multiplying a decimal with a whole number like 100, the first thing that you have to do is take into account the number of decimal places. So this number here is 0.08. This is the first decimal place, and this is the second decimal place. So 0.08 has got two decimal places. We remember that, and we just write it as 8. Then we just say 8 multiplied by 100. If you multiply 8 by 100, it's going to become 800. Then we remember our decimal points. We have got what? 2 decimal points there. So we go here at the end of 800 and add a decimal point there. Then we move to the left 2 times. So we're going to say 1, 2, and add our decimal point there. If we add our decimal point there, it will be 8.00%. But don't write 8.00% because later on when we talk about significant figures, we're going to discover that these zeros at the end are practically not significant. So I'm just going to say 8%. So that's 0.08 as a percentage. Our answer will be 8%. So how did we do that? We just multiply to convert a decimal number into a percentage. You just get that decimal and multiply it by 100, making sure that you count the number of decimal places. So this is 0.08. Step 1, it has got 2 decimal places. Since it has got 2 decimal places, we can now write it as a whole number as 8. Then we multiply 8 by 100, we got 800. Then now we remember our 2 decimal places. We add the decimal point at the end of this whole number 800 and we move 2 times, 0, 1, 2. We got 8.00. These zeros are not significant, so it's just 8%. Is that okay? Make sure you watch this video over and over so that you understand the basic concepts. Are we okay?
Yes.
So our answer here is 8%. I'll be writing the answers this side so that when you get the video, you see the working, you solve in your book, you go back, you see the answer, you solve in your book, solve, and so on. Okay.
Okay.
Let's try solving this fraction here. Let's try solving this fraction here. Times 4, right. Let's solve this fraction. So we're saying now 1 over 3 plus 4 over 7. All right. So how do we add fractions? So the first thing, we're adding these two fractions. We have to look for something known as the lowest common denominator. For me, I do not like calling it the lowest common denominator because it sort of adds, it doesn't make sense. It is the lowest common denominator, but for me, I like to call it the lowest common multiple because it works like this. If we can list down the multiples of 3 here, multiples of 3 include 3, 6, 9, 12, 15, 18, and 21, etc. They can go on until infinity. Then multiples of the 7, we can say 7, 14, 21, 28, etc., etc., until infinity there. Once you are listing both the multiples of 3 and you are listing the multiples of 7, the first thing that you will see that they have in common there is the lowest common multiple. So here there's 21, and here there's also 21, meaning the lowest common multiple between 3 and 7 will be 21. If you want, you can just multiply the two denominators. 3 times 7 will give you 21. But that doesn't always work because it will give you a multiple that's sometimes too big, and that multiple will not be the lowest common multiple. So this is why I like calling it the lowest common multiple and not the lowest common denominator, because you get it from listing down the multiples of 3, the multiples of 7, then the first one that you're going to find that they have in common there is the lowest common multiple, but you can call it the lowest common denominator because that's what they call it throughout mathematics. But for me, I call it the lowest common multiple, but we'll be calling it the lowest common denominator. It doesn't really matter. But math has to make sense. Same with science. If what you're doing isn't making sense, then you're going to hate the subject and it won't make sense. So here we now have our lowest common denominator, or our lowest common multiple between 3 and 7, which is 21. So the first thing that we're going to do here is that we're going to divide, right? We're going to say 3 into 21. 3 into 21, it would be 7, right? So if we divide 3 into 21, it's 7. Then we're going to say 7 multiplied by 1, it would be 7. Then we're going to do the same on the other side. We're going to say 7 divided into 21, it would be 3. Then we're going to say 3 multiplied by 4. 3 multiplied by 4, it would be 12. Yeah, it's 12. So I'm going to say plus 12 there. Then we add, this will be 7 plus 12. It will give us 19. So our answer will be 19 over 21. This is a proper fraction, so we can leave it just like this. And 19 is a prime number, so we can't reduce this any further. So this is how we add fractions. So how did we do that? First of all, we found the lowest common multiple, a number that's big enough such that both 3 and 7 can go into that number without leaving a remainder. And we found that number to be 21. Then we said 3 divided by 21, it was 7. Then we said 7 multiplied by 1, it gave us 7. Then we went on this fraction here. We said 7 divided into 21, it's 3. Then we said 3 multiplied by 4, it's 12. Then we added these two. We said 7 plus 12, it's what? 19. So our answer, we now have a proper numerator there, 19, and a proper denominator, which is 21. This is a proper fraction. So our answer is 19 over 21. Are we okay?
Mm.
All right. Revise these exam questions. So preparing for the exam has begun. So make sure you revise. Every time we'll be looking at some exam questions. So here it is 19 over 21 as our final answer. So let's evaluate number 4. Number 4, back to decimal numbers. Those numbers that have a decimal point. How are we supposed to multiply decimals? How do we multiply decimals? So we're trying to evaluate 0.4 multiplied by 0.06. So step 1, when you are multiplying decimal numbers, you first count the number of decimal points that we have. So here we have got one decimal point, and here we have got how many decimal points? 1, 2, 2 decimal points. Therefore, in total, we have got 3 decimal points. Then we just remove this part here because we've counted the number of decimal points that we have. We can remove these zeros. Therefore, we are going to have 4 times 6. We'll have 4 times 6. 4 times 6, it will give us 24. So 24 is our answer. However, we have to go back to this. The number of decimal points that we counted 3 decimal points. So every whole number, let me say this, every whole number that you write, the decimal point will be at the end. If I write 4 as a whole number, the decimal point is there at the end. If I write 26 as a whole number, the decimal point is at the end there. Therefore, 24 as a whole number, the decimal point is also at the end there. Since we had 3 decimal points initially in total, we're going to move 3 times. So this will be 0, 1, 2, 3. So our decimal point will be there. There's a gap here, so we'll add a 0 and a 0 there. Therefore, our answer will be 0.024. I'm going to go through this again. Every time when you're multiplying decimals, the first thing is that you count the number of decimal places that we have. So this one, 0.4 had 1 decimal place. 0.06 has got 2 decimal places here, 1, 2, 2 decimal places. So in total, we have got what? 3 decimal places. Then you forget the zeros and you just multiply 4 by 6, which gave us 24. 4 times 6 gave us 24. It gave us 24. And we said any whole number, the decimal point is there. So we're moving 3 times because the total number of decimal places that we have is 3. So we move like that, 0, 1, 2, 3. We add the decimal point there. But there's a gap here, so we add a 0 there and a 0 there, meaning our answer is going to become 0.024 as the final answer. Are we together?
Yes.
All right. Okay, that's good. So let's move on to our last question. Our last question is a mixed fraction. Our last question, 2 mixed fractions actually, and we have to subtract. So a whole 3, 5 over 9, minus a whole 2, 2 over 3. So the first thing that we have to do here, our step 1. Step 1 is that we have convert the improper fraction, fractions to mixed fractions. So that's our step one there. So how do we convert an improper fraction into a mixed fraction? We multiply, then we add, right? We multiply and we add. So let's multiply this side. We're going to say 9 times 3. 9 times 3 would be 27. Then we're going to say 27 plus 5. 27 plus 5, it will be 32. So this side we're going to have 32 divided by 9. So we have converted this mixed fraction into an improper fraction. Minus, this side we're going to say 3 times 2, it would be 6. 6 plus 2, 7. Of 6, 8, 8. 6, 7, 8, right? So we're going to have 8 over 3. So we've converted, yes, excellent. We've converted these two mixed fractions into improper fractions. Then the next thing now, we just have to solve this fraction. Where's my case? All right, we have to solve this fraction there. So between 9 and 3, our lowest common multiple. So if I can list the multiples of 9, I've got 9, 18, 9 plus 9, 18, then 18 plus 9, that would be 27. 27 plus 9, that would be 36, etc. Then multiples of 3, 3, 6, 9, 12, 18, etc. You've seen that they have 18 in common at 18 in common. They have a 9 in common and a 9 in common, meaning the lowest common multiple between 9 and 3 is 9. And I like to call it the lowest common multiple, not the lowest common denominator. If you add 9 times 3 to give you 27, 27 is a denominator, but it's not the lowest. No wonder I like to call it either lowest common multiple, because you are listing down both the multiples of 9 and you are listing down the multiples of 3. Then you are trying to figure out which one is the first one, which one's the lowest one. So the lowest common multiple is 9, and it's not 18, it's not 27. So it's not 19, it's not 27, it's not 18, but the lowest common multiple is 9. So we now have the lowest common multiple as 9. Then we solve this fraction. We say, I have to write the answer this side. So we divide and then we multiply, right? We divide and then we multiply. That's how we solve fractions. So we'll say 9 divided by 9, it's 1. 1 multiplied by 32, it will be 32. Then we're going to say 3 into 9, 3, 6, 9, that's 3, right? Then we're going to say 3 multiplied by 8. 8 times 3, it would be 24. So this is 32 minus 24. If we say 32 minus 24, 32 minus 24, we're going to get 8. So our answer will be 8 over 9 as our final answer. So this is how we solve these fractions. We first have to convert this fraction into an improper fraction. How do we do that? We multiply and add. We multiply and add. We've got 32 over 9 minus 8 over 3. Now that we have improper fractions, we can solve this fraction. We have the lowest common denominator, which is 9. Then we divide 9 into 9, 1 multiplied by 32, or 9 divided by 9, it's 1 multiplied by 32, it's 32. 3 divided by 9, it's 3. Then 3 multiplied by 8, it gave us 24. So we're saying 32 minus 24 gave us 8. So our final answer would be a proper fraction, which is 8 over 9. So that's the end of our first lecture in mathematics. Next time we meet for math, we're going to do addition of algebra, subtraction of algebra, multiplication of algebra, expansion, and factorization. We're going to end on factorization and we'll do a lot of questions on factorization. Then our next lecture, we're going to do changing the subject, substitutions, and algebraic fractions. Then we're going to call it an end in algebra. So we'll have 3 sessions for algebra so that you understand algebra well enough, because I told you that this topic is math itself. Without you learning algebra, if you don't understand algebra, math will be hard. But if you understand algebra in proper detail, math is going to become very, very simple. So but we're going to end here today. So I want you to buy a math hardcover book, a proper hardcover book, at least 192 pages, so that you write, okay, topic 1, algebra. You have to write down all this in your math book. Write down all this in your math book. Starting from your topic, there should be your date, introduction to mathematics. Then you write your context there, algebra, and the things that we're supposed to do, numbers and 2 algebraic fractions. You write your heads in there. You write down all these notes. You solve these questions plus these questions. Then you watch the video again so that you make sure you understand it. So I recommend that every time I send you a video, watch it at least 3 times. The first time you watch the video, it's to help you understand the notes, to help you write down the notes. Then second time you watch the video will be for you to now understand the topic. Then the third time you watch the video, it will be for you now to make sure that you don't forget, you understand things properly. So just keep watching these videos, until you understand everything properly. So I'm going to end this lecture and I'll send Charity the notes and the lecture video to her. She's going to receive the lecture video by email and she'll be able to download it. Then she'll give you the lecture video. All right, Fabi. I'll see you tomorrow. Bye. All right, bye.